Hi all, thank you for being here today. I hope you enjoyed all the morning sessions and had some good talks already. So this talk is going to be about GraphQL, and I think after this you will all get some lunch. So I hope I won't take too much of your time. So what is this about? GraphQL is a kind of new technology that was invented by Facebook. And this talk will show how you can use it and what are the differences between a REST API, basically like you once had XML to give documents to each other, and now we're using JSON for most APIs. So this talk will show how GraphQL relates to REST APIs and what are the benefits if you would use GraphQL. So a meme I really like about this one is, it's probably a meme you've all seen before with different context. It basically says, like a developer, you see new packages every day, new frameworks, especially when you're working on frontend, backend a bit less, but still. GraphQL is a really new and interesting technology, and for most of the people that are working with REST APIs already have seen problems that we are going to discuss today, and after which you can see how GraphQL solves these for you. So a little bit about myself. My name is Roy. I tweet under the handle @GetHackTeam, so if you want to get more information after this session or want to let other people know you're here and watching this, please go to Twitter. I tweet a lot about JavaScript mostly, but also about React.js, React Native, and of course GraphQL. I started working with JavaScript for 10 years ago, and I taught myself how to work with it, so I didn't went to computer science education. But learning this really made me understand how JavaScript works, and it also shows that JavaScript is open to everyone. So that's why I have the hashtag JavaScript everywhere, because you can use it everywhere, and it is relatable for everyone. So who's this for? Like I said before, it's mostly for people that either work with REST APIs or design REST APIs, or maybe somebody that's a product manager and is looking to get a new project started up. So GraphQL takes a special place. It can be used both by backend developers or by frontend developers. And you can see it as sort of a layer between your true backend, so your database or other REST APIs you might be accessing, and your frontend. So what is wrong with REST? Let's first get started with this. So nothing is really wrong with REST. I really like to work with REST APIs. I've used them a lot, but they can be improved. And some of these improvements we will discuss today. And I might ask some people afterwards if you see other disadvantages of using REST. So let's look about what a REST API really is. So REST has multiple endpoints that return fixed data structures. So usually you have a collection that's is like a user or a product or other information, and your REST API will return that collection in the exact shape how it is described in your collection or your database or in your other data source. And it has multiple endpoints, so each collection will have its own endpoint, and if you want to combine collections, you usually need to have multiple endpoints for that. So we're going to try and create a situation by looking at an example UI. So I've created a little wireframe for you, and it's a product page, so it shows a title and a thumbnail, a rating, and multiple offers. So this is actually a marketplace UI. I'm a co-founder of a marketplace startup, so I use this example as it is an example I see every day. So we have this title and our thumbnail that come from one API call. So we have the API call product/ID, and we're going to get to the basic information. And usually it's a lot more than those 3 variables. It's like an entire list with all the variables you have for this particular product. And next to that, you would have a different endpoint for the reviews as well. So you don't only want to show the product information, but also the review information, which requires you to make an extra request. And then finally, to show all the offers you have for this product, you need to make a third request to show those actual offers. So we have 3 endpoints here that we need to access in order to have our customers see this product page. So you might say, why not create one endpoint to have all this information in one place? So you only need to make one call to the server, and what you get returned is the entire information you will need for this particular UI. So we can do that, and now we have our... so this is a third example for a REST API, and this API call is to products as well. You specify an ID, and what you get back is all the information. So the 3 endpoints we just saw are now combined into one endpoint. So we have a title information, we have a review information, and we also have the information for all our offers. And if you could imagine, it can be a really big request. If you got a lot of offers, for example, if you're Amazon, and you have 100 offers for a certain product, then this will require a lot from your server to access all this data all the time. So we've used something we call a nested layout design. So our API has a nested design. So we don't return one collection, we return multiple collections in one layout. So another problem you can get with this is like under and overfetching. As you can see, we now have all this information, and we have used a nested layout design, and this endpoint is particularly designed to serve this UI. And now maybe your front-end developers are asking to change their application. They maybe want to not show all the offers. So what would happen then? We're going to delete the offers from this UI, and you're going to get stuck with a lot of information that you're accessing all the time. So every time somebody makes a request to your endpoint, they will not only get the product information, they will also get the information about the offers, something that you aren't showing at this particular moment to your user. So something we could do is like specify the parameters you want in your endpoint. So you're sending a request to maybe the product endpoint, and you're saying, hey, I only want to receive the product information, and I also want to receive the information about the reviews. So you're adding parameters to your endpoint to make sure the data that's returned is modeled to the UI that your front-end developers want to show. And this can also be a problem, but hey, maybe we want to change it. We only want to show the latest offer. So we have another parameter that said latest offer true. We don't only request the product information and the reviews, but we also request our latest offer. So you have to remodel your API so it will return the latest offer if you specify the parameter, so your front developers can show it. And as you can see, we only show one offer, and maybe they want to put in some button to show more offers, but that's something we can look at later. So maybe we want to show all the offers again. So if we go back to the previous example, we're now showing the latest offer only as we specified as a parameter, but of course we can also specify to have all the offers again. So now we not only specify that we want the latest offer, but we also specify we want to get all the offers again. So as you can see, the request is getting bigger, and our UI has changed, so we really modeled this endpoint to fit our UI. As you can see, our front-end developers now also want to show all the rest of the offers, but they are hidden between a show more button. But if you use like a nested layout design, they have to make a request for all the offers at once, or maybe they have to do something else and like request the offers again in another API call. So it's not really the true solution to the problem you're facing here, as you still need to make either a really big request to the server that has all the information, or multiple requests to get like smaller bits of the information for your product. And as you might imagine, our application looks really different now. So we have these two UIs. We started with version 1 on the left, and it shows the product information and all the offers. And we have version 2. It shows only the latest offer, and it could show all the offers if a user decided to click on the Show More button. And if you might imagine, we now have different endpoints for our API. So maybe your front-end developers didn't alter the application to serve multiple endpoints, or maybe they did. Or maybe one UI is released to the App Store, and you have to wait for it in order to use the new endpoints. So it's a lot of stuff you need, as a backend developer, you need to maintain. So you've got these different endpoints and these different structures and the different parameters. So you need to have versioning on your API, and maybe some people don't, but at least you have to maintain multiple versions of the API with different endpoints, different parameters, and also different data structures. You might have restructured your data to look different to really fit the UI. And this is something that is, that also needs documenting. So some people might know like this. This is an API, open API schema. It configures how you can document your API, and unless you use some package to automatically fetch your collections and translate it to this file structure, you have to write this documentation every time. So every single time you change an endpoint, or you add parameters to it, or change your data structures, you also need to change the configuration of your documentation. And as you probably all know, you sometimes forget it, or you're really in a hurry, or there are different releases, then it can get really hard to keep this documenting up to date. Yes, you need to specify all the parameters again. And this is something GraphQL can solve. So if you're going to look at some of the problems we saw, it's the multiple endpoints. So you have multiple endpoints for every collection. Another problem we faced was overfetching. So we either use a nested design for API, and we're going to call all this information at once. That's something we call overfetching. Also have something called underfetching, the n+1 problem. It's basically where you need to make another request as your API doesn't provide enough information. That's something we saw in the very beginning, as we have the multiple endpoints. But also if you use the nested layout design, you can also get into this situation. Sometimes your nested layout design doesn't have all the information you need at once. And of course, versioning and documenting. And these are all problems GraphQL can solve. And it all starts with a single endpoint that returns flexible data structures. So different than REST, we don't have multiple endpoints that return fixed data structures. We're going to have just one endpoint that has flexible data structures we can configure ourselves. So if we're going to look at how GraphQL does this, usually when you make an API request, you have multiple solutions. You can either do a GET request or a POST or PUT. At GraphQL, we only have a POST request. So everything you do needs to have a body with information. And if you want to do something we call in GraphQL a query, you would do a GET request in REST. But in GraphQL, you will do a POST request, and in the body, you're going to send all the variables you want to receive back. So we have this POST request, and otherwise, if we want to do a mutation, so we want to alter our data collection, then we will also do a POST request, but this time in the body, we will send the parameters we want to change or want to delete. So as you can see, POST, PUT, patch, and delete would all be considered a mutation, and are also going to a POST request. So it can feel a bit weird if you're really familiar with REST and you know, okay, when I do a delete request, I assume data will get deleted. With GraphQL, you will only have the POST request, and you really specify yourself what's going to happen. So it might feel a bit strange at first. And how GraphQL does this? On the left, you will see GraphQL data scheme. So in this schema, you will provide your collections. As you can see, type product is a collection of all the information we want this type to have. So as you can see, we have our title, our ID, and our thumbnail. And we also specify the relations we have with our reviews or with our offers. And these collections will have their own type in the schema. It will also specify which parameters or variables they can return. So as you can see, for review and offer, we both have parameters and variables connected to it. And as you can see, we also specify in what format they're delivered. As you can see, some are strings or integers, others are a float. And if you look at the relational, you can see we refer to the type in the schema. So as you can see, reviews will return something in the format of their own type review that will all have their types described as well. As you can see, it will return product ID, count, and average that are either an integer or a float. And you can also even make it nested even more. So maybe you want to include all the reviews or all the information you would have related to a review, maybe the user information as well. You can all specify it in the scheme. And yeah, so you describe the data structure. And what we do on the bottom is we specify which information you can retrieve at once. So you're going to set a type for your queries. And people can, in this solution, people could only fetch an endpoint to this GraphQL API, and they can get back a product if you define an ID, and it will have the format as we described for the data structure for product. So if we look at the query example, you can see we run this query, we're going to give an ID, so it's going to match the ID you have in your product schema, and it's going to return all the information you specify in here. And as you can see, we have the relational types described. So we have our reviews and our offers, and we can also specify which variables we want to return for these relations. As you can see, we can set dynamic parameters, and in this case, we only set the ID, but you could also set multiple stuff if you want to select products that fit other criteria as well. And something gets returned has the exact same data structure as the stuff you specified. So if you look at this request before, you can see we ask for, we have a query, we ask for a product, a title, thumbnail, reviews. And if you look at the return, that's JSON by the way, you can see that's the same data structure. So we're going to get back our product, we're going to get the title, thumbnail, and the relations we just described. So with reviews and offers, and as you can see, offers returns an array. As we also specified, offers can be multiple. Yeah, so it's really a predictable return result. You don't only have a single endpoint in which you determine which information you want to receive back. You would also define how you will get it back. So the structure is really related to your query, which makes it really easy as a front-end developer to know what information you will get back. You don't no longer need the documentation to see how, in what kind of data structure will I receive my information. And we can do the same for a mutation. As you can see, we have our type offer. So if you want to add an offer to our product, then this type offer will have its own data schema. As you can see, we have a product ID, which will link it to the product. We have a reseller, which is the name of the company that sells it. And we have a price. And we also defined a mutation. So the only mutation developers could do in this situation is mutate by adding an offer if you specify a product ID, a reseller, or a string. And as you might see, the exclamation mark behind integer will mean people need to put in an integer, otherwise your query would fail. I will show a demo a bit later, and you can see you won't get any result back if you don't specify the exclamation mark, if you don't specify the product ID. So what we will do here is we've described the data structure again. So we're going to add an offer. We're going to add the offer to our data structure for offer. So all the information put here has to match. And then we would also need to specify which information we want to receive back. So we're adding an offer, and we're not just adding the offer to our database or going to adding to another data source. We will also get some information back, and you can specify that after it. And you can also you can only specify the information that is described in your schema for offer. And this will also return like a predictable result. So what you will get back will look the same. So you will get back the offer with the information you just described. And also, if you look at the problem for overfetching again, this is when we would have a nested layout design, and we're going to get all the offers and the reviews in one API request. That's something we can solve with GraphQL. As you can see, we can determine how our data looks like. So in this case, we want to exclude the offers. And what we will get back is the data collection without the offers. So this is something you can see in a demo for yourself. But it's really, like I said before, you define which data you want to receive, and you will get it back in the exact same format. And the same goes for if you want to use pagination. So something that's come out of the box with GraphQL is saying you want to receive the first offer, maybe you want to receive the offer after an ID, something that's really useful if you have like a scroll more option in your API. As you can see, you would still get back the data in the format you described yourself. So there are really no surprises as a front-end developer when you're implementing this. And versioning is also something we discussed before, and it's really easy with GraphQL. As you can see, we have our schema for offer, and we altered it a bit. We renamed our reseller variable to be called reseller name. And afterward, we just put a little deprecated mark, so GraphQL will know it is deprecated. And when people are using the GraphQL documentation playground, which I will show in a bit, then they won't see the variable name reseller anymore. So they can still query it, but they won't see it. So when they're adopting a newer version of your API, they won't be using the old variables again. As you can see, it's deprecated, and we can still query it. But if we look at the result, we will get back both. If we want to have both the reseller name and the reseller, then we can both access them, but your user just won't see a reseller is available anymore once you deprecate it. And this is something you can see in the GraphQL playground. So this is something that comes out of the box with GraphQL. I used Apollo server for this example, so it looks a bit different than GraphQL you might know from Facebook. But it still works the same. So you can see your entire schema here. As you can see on the right side, you can loop through the schemas, and you can see which variables you can access, and you can see the relations, you can click through it all, and it makes it really easy to see which is available in the API and which information isn't. And this is all self-documenting, so you don't need to specify what you want to be available here to a user, but everything that's defined in your schema is available to the user to see and loop through and use in this playground. So let me see if I can. Yes, so this is the example of the playground. As you can see, I have. Let me make this a bit bigger. Yes, as you can see on the right side, we have our schema. You can just click through it. So we specified a data schema for product. And this will be a collection of other products, and you can see the variables you can query. And you can also see the relations, so we have a relation with offers, for example. You can look through it and you can see all the information described here. And if you want to do a request, then it's really easy. You can see, you can do the request right here. We can leave out stuff, we can put it back in. So if you want to leave out the reviews from your request, you can do it like this. And you can see the reviews are missing. Also, we can specify we only want to return the price. And that's something that's really easy as well. And you just put them back in. And they're there again. So your front-end developer can play around to this playground, or maybe you have other users of your API that want to use it to display your information on their website or in the product. Then you can use this playground to see which data structures they can get. And also, if you would look at the variables, this is something you can do. So we describe the variables we want to include in our request. And this request for product, it uses the same data schema as we saw with the request for products. But now we define an ID. And if you look right here down, you can see this is our request body. So all the information you specify here can be accessed in your query to display the data that you want to have. And also you can set HTTP headers. So if you've got information that needs to have a certain authorization level, you can specify and all sort of tokens you can have, and you can fetch those on your server, something I will show you as well. So if we go back to the slides, yes. So how can you implement this? Like I said before, it is a special place between the backend and the front end, and you can also use it as a layer between those two. And now I'm going to look mostly at the backend implementation. Yes, so as you can see, we can either use GraphQL to access a database, which is the most simple structure. So instead of, you can still have your controllers for your API, but this time they won't relate to an endpoint, but they will relate to GraphQL. And GraphQL will handle this on their own way. And not only can you create GraphQL access to databases, you can also use it on existing services. So maybe you have like a legacy API, or you already have like document-based stuff you want to resolve with GraphQL, you can do this really easy. And you can also access third-party APIs. So if you look before at the HTTP headers, if you would have like an authorization token from Facebook or any other social media, you can just send those to GraphQL, and GraphQL can look in the Facebook API for certain information, or maybe you want to register a user to social media, then it's something that can be done as well. And if you want to construct a GraphQL server, it usually will look like this. This example is for JavaScript. But if we see later, you've got packages for any other programming syntax you will use. So something we describe is the type defs, and the type definitions are our schemas. So here we will describe the data structure of our collections. The real magic happens in the resolvers. So the resolvers are your connection between your data source and between your GraphQL queries. So you really need to define the relations between the data in your database or in your external API with your schemas. And once you've got those information set up, GraphQL can query it. And stuff like authorization headers, we can put them in the context, and we can also put connections to a database or to any other API to the context as well. So it's basically three things: the type definitions, which is your schema or maybe your database model, as other people might know it from the REST APIs, and the resolvers are sort of your controllers, and you make the relation between the data and the queries. And in your context, you can set additional information like authorization. So this is a bit more advanced example. And next to context, we also included data sources. And data sources will be put on the context variable, but it helps you setting up and collecting data. So you can make the connections with your data source. And in context, you can put the request headers you might need to use for those data source. And here's a bit more example of a resolver. So we have our schema, and you can see we have a resolver for query and resolver for product. As you might see, the query for product takes in an underscore. An underscore usually is the first parameter, and it stands for parent. It's not really relatable for this one, as product doesn't have a parent. It is the parent actually for the other data collections. As you can see, we can also take arguments. Arguments would be like the ID we set in the query, or maybe anything we want to alter to this particular product. And you can see we will use the data sources. So we will use the data source to get information about this product, and we have sort of a controller that will get this product. And something that's really important to understand is that the format in which you will get the product from the data source needs to be exactly the same as your schema. So it needs to be a JSON, for example, that contains in the same order, not in the same order, but GraphQL will know if you have a data schema for product, and it will return like a really big JSON file with maybe not just the three variables we described, but maybe it's like 100. GraphQL will still take those out of the JSON file if they have the same name. So our query resolver will need to match the design we've made for product. And if you would look at the example we have here for product, we can see product will return the data in the same structure as our schema, and we can send that data to the reviews resolver. And the review resolver will use the parent, in example the parent ID, to either fetch it from your database or another API, and it will link reviews to the particular product. And as a front-end developer, it's really easy to use GraphQL. Like I said before, you can just query it with a post request. So we have this post request, and this post request will be sent to our GraphQL endpoint that is here marked as /GraphQL. And with the post request, you can do the query and either get information, or you can do the mutation, which either post, put, patch, or delete, but all structured in one post request. And what else GraphQL has to offer? It's not just a query language for your APIs or data sources. It is much more, like modern tooling. The playground you saw before is from Apollo, and Apollo has created a lot of products to use GraphQL either in the front end or the back end. We also have a very rich developer community. So GraphQL is still growing each day, and especially front-end developers really love it. It still needs a bit more adaptation from like programming languages like Python is less popular, but still it can be used with this. And it's platform agnostic, so it really relates to different programming languages. You're not limited to using JavaScript or especially JavaScript is really big with it, but it doesn't necessarily need to be JavaScript. And industry adoption. There are a lot of big companies already using GraphQL in the modern day tools. Like most developers will use GitHub, and GitHub is someone that has adopted GraphQL already. So if we look at the developer community, like this is the NPM package for GraphQL. It's sort of the GraphQL source, and as you can see, it has over 1 million weekly downloads. So there are a lot of products already using it, and of course, every time you run npm install, it will count as a download. But still, it's indication that it's really popular right now, and a lot of people are using GraphQL in their applications. And if you also look at the number of dependents, so there are almost 3,000 packages that depend on GraphQL. So you can imagine there are a lot of modern tooling that is already using GraphQL is related to this single GraphQL npm package. And like I said before, it's platform agnostic. If you would search for GraphQL on GitHub, you will find that there are over 20,000 products that have the tag JavaScript, also have the tag GraphQL. And you can see for TypeScript, it's really popular as well. And then you can see it declining, but still, there are other packages that are other GitHub repositories that are using GraphQL. And for example, we have Apollo here, and Apollo is the biggest for JavaScript. You got like Graphene, and you can use it for Python, but you can also use it for Rust, I believe. And Sangria is for Scala, and Ruby has its own package. Relay is something created by Facebook. And you have Prisma, which is mostly used on databases. So you can connect Prisma as a layer in your database, the same way like we saw before, to set up a GraphQL server. And also we have the industry adoption. As you can see, GitHub is a very popular product, probably everybody uses here. And they adopted GraphQL, and they had like multiple reasons to do this, and the biggest reason was actually the multiple endpoints and the fixed data structures from REST. That was really annoying their developers, and also was a really big load on the servers. Netflix recently adopted as well. There's a really good Medium article by the guys from Netflix that created this particular implementation. and other companies like Yelp and Shopify are also using GraphQL. Yeah, to summarize, we can look at the REST has multiple endpoints that return fixed data structures. So this is something that GitHub saw as a big problem, and Facebook also saw as a problem, and that's why they either created GraphQL or started adopting it. And that's one of the main reasons I started using GraphQL as well. Because it's really hard to maintain all the data structures, and when you've got multiple versions, multiple users of your application, and all those applications will configure over time. And REST endpoints are usually structured to match those UIs. So all the decisions you will make to match a particular UI would mean that all the people using your API are getting this exact configuration. And with GraphQL, you will get a bit more flexibility because you have the single endpoint and it will return flexible data structures. So a user can describe how your data will look like and in which format they will get it returned. And also they can exclude or include any variable that they want. And something that's really important, like we saw before, you can implement it either on your existing database or your existing API, your existing controllers maybe, and also on third-party services. So you're not, you can use GraphQL, so single point of truth, and query most of the application, but you can still have your REST application and your REST endpoints next to it. So you're not limited to using GraphQL if you would decide to adopt this technology. You will still have the flexibility to add it to your existing data models. And yeah, so like I said before, XML is still being used, and JSON is like in my opinion, a better alternative, and is getting big, is much more popular right now than using XML. And I will believe GraphQL will become something like JSON, but then for REST APIs. So you no longer have to deal with REST APIs as front developer. You can just go to a GraphQL endpoint and get all the data you would like. And if you want to learn more about GraphQL, you can either go to Twitter and tweet me, or you can go to the website of GraphQL, or something that's really nice and has a lot of tutorials is howtographql.com. And they have tutorials to get you started with almost every programming language, both from a backend side, but also for the front end. So thank you very much for your attention. If you have any questions or want to see a bit more from the playground, please let me know.